that delay, I think is due to my internet speed. I just actually called Fios and got them to upgrade to 1 gig. But they said it won't take effect until tomorrow. Uh, I used to have 1 gig, but then I downgraded to 150 about 3 weeks ago, and I've been having problems ever since then. So I guess until tomorrow, I got to deal with it and put up with it. But what I wanted to show you is this. We were talking about before we went into uh, other subjects about, for example, the hurricane and things of that nature. What we were talking about was the horizon, and you were speaking about the horizon dropping. And hold up, man. I just had it up on the screen. Can you hear me?
Oh yeah, I can hear you.
Okay. Man, this is crazy, man. Can you see my screen?
Yeah.
Okay.
Yeah, I can see you.
And what we were talking, huh?
Yeah, I can see it.
Okay. Do you see a circle
Yeah,
with,
it's got red on it.
yes, that is
Yeah.
correct. Now, what I wanted to show you is this. Just imagine if you are in the middle of the ocean. Now, what we were discussing was seeing curvature left to right versus seeing it moving away from you. You're not actually seeing, per se, curvature with your naked eye moving away from you. You're judging something that's being obstructed or appears to be being obstructed by the water that's in front of it. And this is giving you an ability to see something that you would not see if those objects were not present. So when we look at a boat moving away from us, when we look at buildings off in the distances or mountains, we are looking at an object or objects that allow us to be able to judge the height of those objects against the horizon. So without those objects, in other words, we would not notice that. When we look at Soundly's observations, we are we have an object or objects that allows us, based on the angle that we are viewing them and the zoom level of the camera that's involved, allows us to see something that we would normally see if the objects were not present. So what I'm saying to you, as we elevate, now we're speaking about curvature from left to right. If you look at this circle I have here, the horizon from your eyes, if you're in the middle at this red dot, the horizon from your eyes, no matter which direction you look in, will be equal distance from your location. So in other words, if the viewer is 6 feet here in the middle and he's looking left, right, up, down, side to side, that horizon will still only be 3 miles approximately from the viewer's eyes. Therefore,
So hold on, hold on.
you,
I got a question.
uh
So
okay,
you're saying looking from left to right is only 3 miles? I only have 3 miles of viewing if I'm looking at
no,
something
I'm
from
saying
left to
to
right.
the horizon.
To
If
the
the viewer's height is 6 feet, the horizon will always be approximately 6 feet if you're on a level surface. So, in other words, if you're standing on top of the ocean, you're in the middle of the ocean, okay? Nothing is around. You can't see no buildings, nothing, all right? That horizon, whether there's buildings there or not, the point is that horizon is approximately the real horizon is approximately 3 miles away from your eyes,
okay.
no matter which direction you're looking in. Okay.
All right.
If that is the case, then that means even if you're looking left to right, you're still viewing a circle. So in other words,
I disagree
if
there.
you
That's where I disagree. It's not okay. Okay, go ahead. Go ahead.
let me explain. If I'm this red dot here in the middle, right, and I'm looking, just say if this circle right here or the circle is 3 miles away from me, okay, and I'm looking straight ahead. If I'm looking right here, if I'm looking this direction, if I'm looking this direction, it's still only going to be 3 miles away from me, according to the globe. Now, if you are speaking of something else, that's different. But based on the globe, the horizon is 360 degrees around you if you're in the middle of the ocean, for example, and it will be equal distance no matter which direction you're looking at.
So,
do you understand what I'm saying?
So say I was in the middle of the ocean, and in that view, 360 degrees around me, there were buildings lined up all around that. You're saying all of those buildings would be 3
No, I'm
miles
saying the
from my
horizon.
from
The
my
buildings have nothing
yeah,
to
because it's a
do.
false horizon. That's what I'm saying. It's a false horizon. We only can see so far. But as far as the two, say it was, and I can't point to what you got on the screen, but say, from the same reference in the middle, you're looking at
Okay.
something at about 250 degrees. And then you
Okay,
can
you
see
see the
something at
250
about
degree marker. Okay.
110 degrees. Those two objects, the distance between those two objects is more than 3 miles, right? Like
Between
that's
those
got
two objects, but from your
right.
location, they're not.
So from my location, they're not.
They're not.
But still, the fact remains the distance between those two objects is more than 3 miles. And it could be, let's say 20 miles. Is that too much? Now, over a 20-mile.
No, it is too much, because if it's 3 miles away from you, then that means it's approximately 6 miles, give or take some feet from each other.
And what's the reason that I can't see the curvature between those 2 points if they're 6 miles away from each other?
First
Which
of all,
is, a
those two
substantial amount of curvature.
First of all, those two locations, is equal distance from your eyes. Okay, so what I'm saying to you is this: look at the top of this part from corner to corner. When you look at the horizon, it's natural to assume that you're looking corner to corner versus looking at a circle like we see in the middle. See, if you were able to see corner to corner, then that means straight on would be shorter or closer to you than the corners would. Therefore, you would be able to easily or better notice a curve than you would if you're looking at the horizon at 6 feet up. Why? Because the horizon is always equal distance from your eyes in any direction. Otherwise, I mean, it's not an arbitrary distance based on the globe now. It's based on your height or the viewer height. Only thing that affects, well, I'm gonna just stay right there. Based on the globe, the horizon will be at a distance based on the height of the viewer, or the eyes, or the view level, eye level of the viewer will determine where the horizon will be. And it ain't looking in a certain direction. You don't say, well, the horizon is 3 feet when you're looking a certain way. No matter which way you're looking, if you are in the middle of the ocean, the horizon is at that height. Unless you're dealing with exterior things like tides and all that type of stuff. But I'm just keeping it simple. The horizon will be the same distance from your eyes, regardless of the direction you're looking in. But the reason why you're not going to notice a curve from left to right is for this very reason: is you're not looking corner to corner to corner. You're looking at a circle, and therefore you would not expect to see it. However, if you take a drone, right, that has a field of view of at least 78 degrees.
Well, hold on, Jermaine. Because
Okay.
let me put it to you like this. Like we looking at this diagram, right?
Okay.
Now each of those lines, let's say, is 3 miles, right? That's my each of those lines playing out on that top hemisphere circle is 3 miles, right?
Yes. From
That's
the
my
viewer.
field of vision. But if I measure from say like the 250 to the 110, it's not going to be 3 miles. And there should be curvature that I could see if I'm panning, right? I mean, this is how I'm thinking about it. Now, you tell me if I'm wrong, where I'm wrong at. If I'm panning from the 110 to the 250, which is say, let's just say 6 miles or 8 miles or something, there's substantial curvature that I should see left to right. Why am I not seeing
Th- this is where you're having a problem. First of all, you're saying panning. In order for you to look in both of those sides, you would have to pan. You frame in one shot unless you have a camera to take that shot with. Therefore, you're trying to judge a curve on the surface of an Earth that is almost 25,000 miles in circumference by panning with your eyes. Come on, brother.
it? Yeah,
Why would you
I can see
expect
what you're saying, but
like that?
it curves equally all around, right? It curves equally all around.
Of course, virtually. I mean, based on you being able to see it, what you can judge with your eyes. Now, if you got measuring tools and sensitive, accurate measuring tools, then you can be able to measure different things. But this is my point. You can go up in a drone or take a drone picture, which there are multiple people that have done this. And if your field of view is at least 78 degrees from 1,600 feet above the earth, you can take a snapshot of the horizon. You can take that picture and you can put it in your, what I done, I took it and did it in PowerPoint. I'm kind of afraid to try to pull something else up, but I'm gonna try anyway. I start sharing. In the meantime, let me try to pull this up while we're talking. But if you take a picture, that picture that you took from the drone at 1,600 feet up, and you take that picture and compress it, you will see the curve of the horizon.
So, okay, man. The camera lens has nothing to do with that.
Hold up, hold up. Before I answer that, now flat earthers show pictures all the time of drones. I mean not drone, but weather balloon footage, and they say it's flat, and they don't have no problem with that. They don't mention the camera or none of that. But when we see curve, now is a problem with the camera.
I mean, to be honest with you, using this argument is not one of the arguments that I like to use, just because of all the conjecture that goes with it, and what kind of lens did you use, this and that, how high was you, and all of this. I really don't like to use the horizon rising to eye level argument, but I'm just saying, you compressing a picture, I just think about it being some kind of distortion there that may show that little slight curve that you're trying to imply is there.
Okay, but
Let me ask you this, because I don't know.
Okay.
Is what's his name? Soundly? His pictures, are those compressed pictures also?
Well, there's they are compressed because they're zoomed in. So you're able to see a long distance, but it appears short. Like, for example, I'm looking at his pictures now, And those power lines, just looking at the picture, they look like they are very close, but they're far apart. And you know,
Why is it
even
that Soundly is the only one coming up with these amazing
he's
curvature
not the
pictures?
only one. He's not the only one coming up with you said amazing pictures. Actually, Soundly just did a live stream yesterday showing how a flat earther went and made similar observations, and he kind of gave a little praise, so to speak, to the flat earther for showing some of the video or pictures that agree with Soundly's observations. Whether I don't know if the flat earther agrees with him, but what the flat earther showed is similar observations that Soundly made. So if you
Who?
actually, when you get the opportunity, if you go to Soundly's channel, you will be able to see that live stream from yesterday.
Oh, it's just. I'll check it out. If it was yesterday, I'll check it out.
Mm-hmm. Mm-hmm. But all I'm saying is that there are things that we can do. It may some things may cost a few dollars, of course, to get the cameras and drones, etc. But if we are really truth seekers, we can definitely do these things. I don't know if you know me personally. I am considered and am a C5 quadriplegic. You know what that is? You know what a quadriplegic is?
Nah, explain.
A quadriplegic is a person that I had an accident. Is a person that doesn't have use. You're paralyzed, and you are unable to use your four limbs normally
I'm
or at
sorry to
all.
hear that. I'm sorry to hear that, man.
Oh, that's okay, brother. I still work. I'm able to use a computer, and I'm able
Right.
to, make a living for myself. And my wife doesn't have a problem, so I'm good.
God
You know what
bless
I'm
you,
saying?
man. God bless you.
Thank you, bro. I appreciate that. So what I'm saying is, in order for me to do certain observations, of course, I have to have assistance. And that's one of the reasons why I haven't done as much as I would like to do. And but eventually I will get around to some things that I would like to do. But getting back to our subject, I don't want to get off subject, is that these observations of the horizon and the horizon drop, we can also do that with a drone. As we elevate, we can have something that would judge the horizon level, and we can measure the horizon level. You can actually uh, do this with a theodolite app. Also, you can judge the horizon drop based on your elevation. These are things that we can do readily. And one of the arguments that I hear flat earthers come back with is that things like that's not the true horizon. Now it's something else. But I'm saying that we can make these observations ourselves. Hello?
Oh yeah, I'm here. My bad.
Oh,
I mean, like I said, the horizon rising to eye level is not something that I've tested myself, and it's not an argument that I usually bring up uh, just for that fact.
okay.
Um, I'm a real, like I said, it's just how I feel. I feel that the burden of proof, like I said, is just on the globe with a lot of the simplistic things. Um, and I haven't seen all of I haven't seen everything. I got a job and a family to attend to. So, Well, most of my little free time that I do get, I do try to, lend that to doing some research. But yeah, so the horizon rising to eye level is one that I just don't really, talk about or use when I do have these conversations.
Okay. Okay. So
And like I said, I am a true seeker. I'm out here. I don't have no agenda to push. I'm not, this is something that I'm invested in. I'm trying to find out the truth. So
okay.
I'm
And
not one of these flat earthers who's like, got something they trying to defend and can't, come to grips with certain things. But
okay. Well, what I say to things like that is that when you
and I will
are
hope y'all will have that same, sorry to cut you off, but I will hope y'all will have that same, you know, mindset when talking to flat earthers and looking into the flat earth is that same mindset. You know what I'm saying?
exactly, I do have that mindset of being objective. I think to a degree, it's easy for us to be biased. As I said in my first video I made, is that we basically assumed, I'm being among many, that the standard globe model was common knowledge. It was just fact. It was no argument there to be had. And so I just accepted it. I didn't necessarily consciously choose to believe in this globe model. I just accepted it because I thought it was common knowledge.
Right.
Okay. And so I really don't have no attachment, no emotional attachment to that. But what I said, the difference is in the average flat earther, and I'm not saying all flat earthers, is that they chose to believe in the flat earth. Okay. When you make a conscious choice to believe in something, naturally you have an emotional attachment to it because you chose that. And when you consciously choose that, your ego is involved in that choice. And we know there's other reasons why flat earthers, some flat earth, I'm not accusing all flat earthers of this, but that they want to believe in the flat earth because somehow they believe this confirms the reality of God. And so that's another thing that,
No, see, I'm not one of them because, like, even with the globe model, as perfect as all this stuff that has to be this perfect, that the globe model points to a creator too. All this atheism stemming from the globe, evolution and all this, it's crazy to me because I think the creator points to both of them. Either
okay,
way you want to slice it, you know what I'm saying?
okay, I agree with that. So let me just stay on this one side then when I'm speaking of believing in the flat earth. So what I'm saying is that when a person has an emotional attachment to a choice, it is harder. Anytime you have emotion involved, it distorts reality, or it clouds perception
Well, let
of
me say
reality.
this
Uh-huh.
that you gotta agree with is that the body of evidence, like, and as far as leaning to superiority, your scientists, whatever you getting your information from, the body of evidence is gonna be on the globe side.
Of course.
So that's not something that, like, I don't want this to be no debate. It's not a debate, but we're having a discussion, and I'm letting you into my mind. You know what I mean? For you to understand, or whoever's listening to understand how flat earthers came to the conclusion, you know, what we think, we don't have explanations for everything because this is a deception that we believe that we're under, you know what I'm saying? So
Mhm.
it's just that y'all always gonna have the body of work there because for the past however many years you want to say we've been under this quote unquote deception. I'll put quotes on it because you know this is still a discussion. You know, I think
Okay.
that's just what it is. we're not going to have all the, I don't claim to have all the answers. I got a lot of explanations. I think there's different explanations, okay, for what we observe. And they not even, you know, given that alternative, you know, explanation and weighing the two. They just giving you the globe, saying this is what it is, and you're supposed to believe that. And all flat earthers are doing is challenging that. And there's nothing wrong with it. I don't see nothing wrong with science because it's all science is always ever growing, it's always changing. So that's what flat earthers is doing. We you know, just challenging the mainstream ideal, and there's nothing wrong with that. We shouldn't be looked down upon. We shouldn't be chastised in any way. You know, we just challenging the mainstream ideal, and I see that as 100%. You know, okay.
I see no problem with challenging mainstream ideas. I see no problem with challenging the shape of the earth. The thing, or the main issue, one of the issues that I have with it is that if you don't believe that there's evidence for a globe, or that the evidence doesn't actually prove anything per se, but yet the only thing you're saying that you're using to justify believing in a flat earth is your senses. And at the same time, there are things that I can point to with observations that we can make in the natural world. I'm not talking about nobody making a drawing or a picture that tricks your eyes. I'm talking about stuff that we can view in the natural world that our senses are telling us one thing, but yet flat earthers say, well, that's not what's happening. So in other words, if it doesn't agree with flat earth, then I don't trust my senses on that. But when it agrees with flat earth, then I trust my senses. And that's one of the things I have a problem with, because it's like it's a double standard, or it's like hypocrisy.
So what part of your senses tells you that it's a globe?
No, listen to what I'm saying. Flat earthers say that they trust their senses. It's flat because it appears flat. Okay.
Every
Now,
one
I'm
of
not.
us, every one of us trust our senses, though. We all trust our senses. We use our senses every day. If you walk outside your door and you're using motion, and motion is part of your day, you're using your senses. You know what I'm saying? That's we
No,
all
I agree
use
with
them.
that. No, I'm talking about when flat earthers use the term trust your senses.
Your life depends on you using your senses, man.
No, that's you're taking what I'm saying out of context. I'm not saying it in that fashion. When flat earthers say trust your senses, they're not referring to you walking out a door and you being able to judge, or you driving a car and you being able to judge if you about to hit the pole or not. That's not what they're talking about. They're referring to when you're viewing the natural world, it appears flat. Therefore, that's what it is. The sun and moon appears like it's local. Therefore, that's what it is. It's no going beyond. It appears that way, so that's what it is.
Well, that's the starting point. If you relinquish your trust in the powers that be, you start from the premise of what your senses is going to tell you. If I set out to prove what the earth is, I'm going to start with my senses, right? So,
Of course.
well, I think that's why, you know, at least from my perspective.
But to conclude that the earth is flat, you have to just stay with your
It's like,
senses. You can't go
well,
beyond that.
where's the experiments, man? Proven. Okay, so like you had the little water explanation. Okay. But something like with the motion. What's the experiment that you can prove that if you spinning something and the atmosphere above that is spinning too? Like, do you even agree that 1,000 miles an hour is a fast? Is
A
that fast?
thousand miles an hour
Is that
is
fast?
fast to us, but to something the size of the earth, it
Hold
is
on now. But
very
you
slow.
standing on it. Okay, so let me walk you through this, right? Say, okay, so in relation to like space, right? We out in space and we looking at the Earth, right? And it's spinning. It's spinning slowly, right?
Okay.
As you get closer and closer to that Earth, what happens?
What do you mean? Once you get into the atmosphere,
Hold on, just close your eyes and kind of, you know, we
start
out
over
in
again.
space.
Say what you said again.
We out in space, and I ain't even gonna put no distance on it. We just out in space and we're looking at the Earth.
Okay.
It's spinning. How fast do you think that Earth is spinning, or how fast would it look to you out in space?
It'll look like it's not moving.
But you'll see the rotation. You'll see the spin of it.
No. Do you see the rotation of the hour hand on the clock?
Does the hour hand clock move? Yes, it moves.
Okay, it moves.
Second hand. Let's talk about the second hand. And we watching the second hand move. That's
but it's not moving that fast. That's what I'm trying to tell you.
Okay,
1,000 miles an hour.
Yeah.
Looking at the
so
Earth,
we out in space. Right, we out in space and we looking at the Earth, and it's not moving that fast. But as you get closer and closer to that Earth, it's going to start spinning faster and faster as you get closer to it.
No, it's not.
Why not? Why not? So when you're driving in your car, the trees that's closer to you in line are not moving faster than the trees that's far off.
Brother,
that doesn't happen. The closer, I mean, where's the 1,000? If you agree that 1,000 miles an hour is fast, and see, this is what I talk about surface speed. Like we standing on the thing that's spinning 1,000 miles an hour. That's fast. However you try, I know the Earth is big, you know, and y'all try to say it's slow in relation to the 24-hour. It spins once in 24 hours, but the Earth literally is so big that it has to spin fast. Like a lot of land has to move to make that one rotation. It's only one. Y'all should say only one rotation. It's only one rotation in 24 hours. Like that shit has to spin fast to make that rotation, and you standing on it. Okay, so back to space. As you're in space and you're getting closer and closer to the Earth, it would start spinning faster and faster. Let
me tell you why it won't. Let me tell you why it won't. See, you used an example of something closer to you. If you're driving down a highway, for example, and something further on in the distance not appearing to move as fast. But if you take an hour hand on the clock and you're looking at it, no matter how close you move to that clock, it's not going to appear to move faster.
That hour hand is not going. Put a miles per hour on it. You know, put some kind of speed on that hour hand.
Okay, this is what I'm gonna do. Right.
We're talking about the surface speed. Do you believe that the ground is in motion?
Okay. Let me share my screen. I want you to see something.
All right.
Okay. I'm sharing my screen. Can you see it?
It's like okay, now I see it.
You see that?
Yeah. The Earth.
Okay. That's the Earth according to Celestia, which you can pick any solar eclipse, for example, and where the path of totality would be, and I can put that date in here, and I can show you it on this program. Right now, let me move my cursor. Right now,
I just want you to. We'll finish this point.
I just want to let me do this before you explain. Let me do this before you explain. This is real-time speed. September 13th, 2018. Real time. Mm-hmm. This is how fast the Earth at over 1,000 miles per hour is moving. This is how it looks. No matter how far away it is.
See that? I don't.
No. So if I move away from it, let me move far away from it. No matter how far away from it I am, no matter how close I get, real time is not going to look any different. Now, if I speed up, now let me just show you something. I can speed it up. This is 1,000 times faster than the speed. So this is the Earth rotating 1,000 times faster.
So you're telling me as you travel closer to that, the speed at which that's spinning won't
So
get
okay,
faster.
like I said, I'm moving it 1,000 times faster. Let me back up. Let's see if we can, if it looks like it's moving faster when we get close.
This is a program. I'm asking you. This is what we're talking about. Critical thinking.
But this,
I
no,
just
but this
gave
is
you.
giving us a picture of what we're looking at.
I just gave you an explanation or an example in real life of this happening. When you're traveling down the road in a car, the trees, if you try to focus on the trees that's right in your face, they're going to be whizzing right by you because they're so close to you. As you look at the trees that's in the distance, you can focus on them and they're moving by slower. So as you get closer to that earth, it's going to get faster and faster the closer you get to it. Any other thing?
You're misunderstanding that example. The example you're giving is if I'm riding down the highway and I'm passing, so you're talking about perspective. As I get closer to a thing, it appears to move fast. As I move away from it, it appears to move slower and slower as I move away from it. But that's not talking about rotation. That's talking about the speed relative to you and your position. As you move closer, the rotation doesn't have anything to do with how fast something looks like it's moving past you or towards you.
Your relative location is changing though because you're traveling closer to it.
Yeah, but if I spin a ball on my hand, a basketball on my hand, if a person is further away and they can see that ball clearly, as they move closer to it, the ball is not going to appear to move faster. The ball will just appear to get bigger. That's it. So what I'm saying is something moving into your view like a light pole or something like that. You can't compare that to a rotation. It's different. It's a whole different phenomenon.
Well, the rotation is around the sun. We're talking about the spin.
No,
the rotation is around the sun.
No, the revolutions is around the sun. The rotation is the Earth on its axis.
Okay.
So what I'm saying to you is, I just showed you how you would, if you're in space, what you would expect to see with an Earth moving at, let me go back to real time, at 1,000 miles per hour. This is what you would expect to see. Why would you expect something different? It's 1,000 miles an hour.
Okay.
If you sit here for 24 hours and look at this program, it will spin one time in 24 hours. Or a little bit less than one complete time in 24 hours. That's how fast the Earth is moving. Okay, let me say it like this. All right, if you're 6 feet tall, this is just a hypothetical, just to give you a picture of what I'm saying. If you take a person that's, let's say, I'm getting real crazy with it. Let's say 600,000 feet tall. All right. You 6 feet, that person is 100,000 times taller than you or bigger than you, put it like that. Like the same dimensions, but they're that much bigger than you. Okay. And just imagine you on a surface and you two are walking. How would it look for you if every step you take, I know we ain't Bobby Brown here, but every little step you take is 2 feet. Just say if you cover 2 feet of distance for every step you take. And that's 1/3 of your height. So 2 feet is 1/3 of 6 feet. Right? Okay. So every step you take is 1/3 your height. Okay. This person that is 600,000 feet tall, for every step they take is 1/3 their height, which would be 200,000 feet. Okay. That one step for that 600,000 foot person would cover over 35 miles in one step. Just imagine you how
holding
you
on
would
to
look
his
trying to cover
leg.
35 miles.
Just imagine holding on to his leg while he's like walking. And you're standing, or you know what I'm saying, you are a part of him and he's walking. Are you gonna notice anything?
See,
I mean, this is an
you're
analogy you brought me down. I mean, it's just my question is really this. So the way you're saying it, the way you're trying to explain it is that we can never experience. I asked you, was 1,000 miles an hour fast? You said yes. You're
yes,
standing
if
on
you're moving through
something
the
with the
atmosphere on the
surface
earth.
speed, with the surface
Mhm.
speed
Okay.
of 1,000 miles an hour, which is kind of like you're never gonna travel 1,000 miles an hour probably in your life.
Yeah. Mhm.
I mean, it's
But you're
just
judging. Go ahead.
I'm judging what.
You're judging that based on something moving through the atmosphere of the earth. Something, an object that's much smaller than the earth. That's what I'm saying. You're judging it. You're making a false comparison. You're comparing a
Okay, so
thousand miles
let me
to an
give you
ant.
a better
Huh?
comparison.
Okay.
And I'm gonna go back to the spin ball, like a globetrotter spinning the basketball on his finger, right?
Okay.
And it's an ant on that spinning ball. Is the ant feeling anything?
Brother. The ant is on a ball spinning multiple RPMs. It's spinning multiple times in a little. Now. I did this comparison. The ant to the to a ball is like, if you compare that to a human to the earth, it's like an ant being on a ball that's bigger than the city of Washington, D.C. Okay. And you spin that ball once every day. You really expect that ant to feel that?
How does that change the surface speed though of what you're standing on?
Because you have to take size into consideration when you're dealing with
Yeah, when I think
speed
about it, it's
and
really
how it would
like,
feel
you
to you.
know, the Earth it has to move that fast in order to make that rotation, that one single rotation. It has to haul ass. We talking about miles and miles of land moving and trying to make one single revolution. It's got to haul ass to do that, and you standing on it. Now, albeit that you say that the atmosphere is spinning with it, but show me that in an experiment where that is going to change into zero for everybody everywhere. You know, everything is all copacetic. Everybody experiences 0 miles an hour. You know, just show me an experiment where that can happen. I guess that's just like the gravity experiment. We'll never see it. We'll never see them re-entering that. You know, I could see you blasting something out of the atmosphere and maybe being okay, but you trying to re-enter that 1,000 mile an hour like vortex that's existing, you know, breakneck speeds. I
See,
mean, I just,
what you're doing, you're making a lot of assumptions.
I'm not making the assumptions. This is what they tell us.
No, what I'm saying with with the assumptions is that you're speaking of breakneck speed, but you're comparing that. See, the mind makes assumptions. We can't discount that we make assumptions when we uh, judge things. For example, do you
Well, I'm just
know?
saying I see what you're saying with the revolution, but I'm trying to get you to picture it how I'm picturing it in my mind. For the person standing on it,
Okay.
that one revolution argument don't matter. You're experiencing the surface speed of what you're standing on because you're upon it. And that speed is fast. That's my
It's
point.
it's fast to something moving through the atmosphere. I had a debate or argument with a guy that was on Been Exposed channel named, I think his name was Derek. And what he was speaking of was a sonic boom. If you go beyond a certain speed, I don't know. I don't want to misquote or say the wrong thing, but I think it's Mark 1. I said it anyway. You would reach or you would break the sound barrier and you would have a sonic boom. This is what he was saying. And he was saying if the earth is spinning at over 1,000 miles an hour, we would constantly hear a sonic boom. And what I was telling him is this is the problem with what you're saying. You're speaking of something moving through the atmosphere at a certain speed and it creating a sonic boom. The earth rotation is not moving through the atmosphere. It's a whole different phenomenon. It's totally different. It's not the same thing. You moving at 1,000 miles, being the size you are through the earth's atmosphere at 1,000 miles an hour is totally different than the earth rotating at 1,000 miles an hour. And this is why it is necessary for us to understand the revolutions per minute, is because anything you on, I don't care what size it is, if it's moving once a day, regardless of what the surface speed is, if it's rotating once per day,
that's where we disagree. I think that's just where we're gonna have a disagreement.
You would have that, but that's one of the discrepancies.
Because in my mind, I'm just thinking of, like I said, you standing, just picture you standing on the earth, and it's got to make this one rotate. Just it's got to move a lot of land in order to do that, and you standing on it, and that land is moving quickly. It's only 1,000 miles an hour. You know, that's just a crazy, like it's only at that. Nah, man, that's fast. And you standing on it. And we can move on from this because I think we had a point where we just gonna agree to disagree. But like I said, and I like to use that from space in my mind. As you get closer and closer to it, you're gonna say you just about to like re-enter the atmosphere. Right then, at that moment, you're gonna be experiencing or seeing that movement, how really fast that is.
See, okay, like you said, like I said, we had a standstill with that. So what do you say to a person? You have people who believe.
Hold on, I kind of wanted you to bring that. I had a question about that. I think you said stellarium or whatever.
No, that's Celestia. It's not stellarium.
Celestia.
Yes.
Can you bring it up to where it can show the relationship when a full moon happens? Is that possible?
When the full moon happens?
Yeah, I got some questions about us observing, a full moon.
Let me see. I'm not far from an expert in this. I had got this program. Let me see something.
Well, let me just ask you then. What do you walk me through what the relationship between the sun, moon, and the earth is when a full moon is occurring?
Okay. No matter what time of day you refer to, no matter what time of day.
Well, I'm picturing it at night,
Okay. All right. With the key thing in understanding a full moon versus the sun and looking at and being on the earth is that, and I'm gonna try to pull it up in here. I'm trying to see what I can do, because you can actually see the moon going around the earth on this. And I actually did this on Bro Sanchez's show one time when we was actually dealing with the eclipse though, and I showed him the angle, because what he was saying was that the angle of the moon or the shadow of the earth should not be coming from a certain angle. From above the moon, it should be coming from beneath or something to that effect. And I showed him how on this.
See, I ain't talking about all the eclipses. I'm talking about just a full moon, just simply a full moon.
Okay.
At night.
Let me see if I can pull
up for every observer. Now, you think the moon is a sphere, right?
Yeah.
It's a sphere, just like the earth is a sphere.
It's evidence of a sphere. How can you have craters with shadows if it's not a sphere?
You saying what's the cause of the craters?
No, what's the cause of the shadows on the edges of the sphere? When you look in the middle, right? The middle of the moon doesn't have shadows. As you can see shadows coming off of the craters on the moon.
You said the middle of the moon doesn't have what?
If you're looking at the moon, a picture of a full moon, right? You're looking at a full moon, zoomed in where you can see the craters. You see shadows towards the edges of the moon and not in the middle of the moon. Okay, that is
All right, let me
indication and evidence of sphericity or being spherically shaped.
okay, so we'll get into that. I have no problem going there, but I wanted to kind of stay where I was at with
Okay.
so yeah, you do think it's a sphere and it is reflecting light, the sun's light.
Okay. Let me
So
just let me share my screen. Let me show you something.
okay.
Let me show you something. Okay. Share. All right. Can you see my screen?
Yeah.
All right. Let me just get closer to the earth. Okay. Oh. Okay.
What is that? What is that spot supposed to be?
I was going to tell you that. That spot is the sun. Okay. All right. That spot represents the sun. Let me see something. If I can let me see something. I used to just know how to go to the sun, man. Let me see.
I'm gonna have to download these programs, man. They free.
Yeah, Celestia. Celestia is free. Shoot. But that light that's shining on the earth is in fact the sun. Now let me what's going on? I'm trying to speed up the motion so we can see the moon come around the back. But I don't know what's going on. But let me do this. Okay. As I move away, look to your right. Okay. You see that coming into view? That came into view?
Yeah,
it's right here.
Okay.
Did you see it?
Yeah.
Okay. Let me just let me come closer a little bit. Okay. Now, I see why it ain't let me just backspace and erase. Okay, that. Okay. Let's see if that'll allow me to speed up the time. Nope. Hey man. It keeps let me see this. Okay, let me try this.
I mean, you can leave it right there, and I can ask my question.
Go ahead, ask your question.
Well, I guess where's the sun in relation to this? Because I just about the full moon. Where's the sun, the moon, and the earth?
Just why you speaking? What I'm gonna do? I'm gonna just restart the program. I'm gonna just restart the program. Go ahead.
Yeah, I just want to know what relation you think that the sun, the earth, and the moon is during a full moon at night for people observing the moon.
Okay.
And how is it that every observer can see a full moon? Like when you look at a full moon, all the edges of that moon are lit. There's not one, like when I think about angles of light on a sphere reflecting off of a sphere, and that being, visually, you can see all the edges of that moon lit up for every observer at night. It just don't make no sense, but maybe you can clear that up.
Well, first of all, if you're on a totally, for example, just say both of us are in night, right? And we're looking at a full moon. And you are, just say 5,000 miles. You're on the same latitude I'm on, but you're 5,000 miles away from me, and we are looking at the same full moon on the same night, right? The moon is far. This creates problem for the flat Earth. You know that, right? Because the moon is far enough away from both observers that we can see the moon in a similar fashion, but it's a little bit of difference. You see a little bit different than I see, maybe a couple of percent different than I see of the moons. A very small percentage different than I would see.
What do you mean different? And you're talking about the full moon?
Yes, I'm saying just put it like this. Just to keep things simple. Just say if I could see a crater right at the edge of the moon, right? But like a part of a crater, you may be able to see more of that same crater on the edge of the moon, a little bit more. You have to actually measure the difference, but pretty much we're looking at the same full moon. Now, let's bring the moon locally. Now this applies to what you were saying earlier about the light post being close to you, you passing it versus something further away. Now, if the moon was as close as flat earthers say it is, it would have to be on a flat earth. If I'm 5,000 miles away, if it's a flat disk, if it's a sphere, that moon would not look the same to me as it looks to you.
Well, I don't claim, all those things you said, but I don't really put like a tangibility on the moon or sun. They are lights in the sky. I know the moon. The moon looks like a rock. I admit that it looks like it's rocky.
Oh, but it's not.
But then I would ask you: have you ever seen a rock reflect light like that, like glow like that? Like even when they landed on the moon, the pictures they show you, that shit ain't glowing like that. That shit look like damn dirt when I walk outside. It's not glowing and giving off light like when they up there saying they own it. So you think that dirt or rocks can reflect light like that? And what kind of rock is that? What kind of dirt is that?
No, you see, now you're bringing in the other factors. You said it looks like a rock, right?
I think if you look up at the moon and you say that shit don't look like a rock, you just, like I said, I'm not a flat earther who's I ain't got nothing to defend, I'm out for the truth. So I just think flat earth is the truth. Where I'm at right now, that's what I think.
Okay. But, getting back to what I was saying.
Or back to what I was saying about this, like you just picture it, it's a sphere, right? And it's reflecting light. And that light can be seen for every observer. Lighting up that whole moon, don't matter where you at.
Yeah.
Because it's far away.
Yeah, because it's far away.
So where's the moon, the sun, and the earth at in relation? Like, is it like are they like at like if you drew a triangle in space, is it kind of like that relationship? You know what I'm saying? Each of those points of the triangle, like the earth is one, the sun is one, and the moon is the other. I don't know if you can picture that.
See what I'm about to do?
Because, the sun, if it's nighttime for us, the sun is on the other side of the earth, right?
Yeah, the sun is always on the opposite side.
Okay, it's giving the light to the other side of the earth. I guess it's how I should word it. So how's the sunlight reaching the moon to where we can see the light reflecting off of the moon, but it's not lighting up none of the atmosphere around that? It's nighttime.
Because the light from the moon is only reflecting a small percentage of the light of the sun, number one. Number two, the moon is not its own light source. Number three.
Let me ask you again. The sunlight is going around the earth, reaching the moon, right? that we're all observing. Yet we can't see none of the sunlight that's hitting the moon. Correct?
You're in the shadow of the earth. You know, he hates real shadows. You know that, right?
Okay, so the shadow of the earth, me being in the shadow of the earth. So like when that red, what is it called? The blood moon? The same sort of things have the sunlight. They say it's red because the sunlight was going around the earth and creating that red tint. So
yeah,
why
but
isn't
that's
the full moon
shining on the moon?
Why isn't the full moon?
Let me
red?
show you something. I found a good picture here, right? You see that? You see that moon right there?
Hold on, it's coming up. Takes a little while. Okay, yeah, I see it.
See that moon?
All right.
Okay. Now I can let me see. Let me see. Okay, let me reverse the field. I can reverse it. And let me speed it up. Okay. You see that? Now I get to when it lines up, right? Pretty much. Right?
All right, where's the sun at?
The sun is directly behind on this thing. Now, what I'm gonna do, I'm gonna just see how to look at the sun, because we can look at the sun actually from this location. But I'm gonna show it to you in 1 minute. Let me just pull up my little, my little directions of how to look at the sun. And I used to know how to do that, but I don't.
You understand my question though, right? With like the blood moon, they said that the sun rays was causing that red tint, and it was stretching around the earth. That's the same thing that's going on during the full moon, right? That's the same phenomenon that you're saying is going on. So why isn't the full moon red in tint too?
See, when you got a blood moon, right? When does that usually happen? What do they globe model say that?
I guess near an eclipse. Is that?
I'm sorry, say that again.
Near an eclipse, like when an eclipse is about to happen or after it happens.
Okay. Telling you. Can you still? Oh man, my computer. Let me see. That's why I won't be wanting to pull up stuff. Can you hear me?
Yeah.
Okay. When the moon is almost directly in between the moon and the sun, right?
Hold on, say it again.
The sunlight is shining through the Earth's atmosphere as it relates to the moon. In other words, the moon is low enough in its position between the Earth and the sun, or the Earth being between the moon and the sun. The moon is low enough in its position that when it's reflecting some of the Earth's atmosphere, or the red light that gets through, because red lights are, or the when you look at the light spectrum, when you look at a rainbow, the red light is always on the outside rim. Why? Because ultra red light is, the waves are longer. Okay. So they're able to go over they're able to go over a curve better than the shorter wavelength lights. Okay. The moon is at a low enough angle to the earth that some of that light from the sun is shining through the earth's atmosphere onto the moon.
You said the red rays are longer, so they should be able to. So does that mean that
that's why the moon looks red? Because the ultra red, the ultra red light rays, ultraviolet, no, the red light rays in the light spectrum
Does that
longer.
mean my question is, does the red light being longer in the spectrum mean that it can shine further? Is that
They
a
can
safe
go
assumption to
around
make?
longer. Put it like this. They have more of an opportunity to shine around the curve. This is why when you look at when the sun sets, right, and you see the light change from yellowish to oranges to reddish, right? That red light, you will see that more towards the end. Why? Because the light waves from that red light, the wavelength is longer.
So when the moon is in a position of the full moon and the moon is farther away in a different position, how come the red light isn't reaching that?
Because it's
And
not going through the atmosphere.
so the atmosphere makes it.
Exactly. If the moon is at a certain angle relative to the earth and the sun, then you will see the light shining through the earth's atmosphere onto the moon. But if the
So during
moon,
a full moon, right, that
okay,
sunlight that we see reflecting off of the moon is not passing through the Earth's atmosphere at all.
hold about your voice cut out. Say that again.
When we witness a full moon,
Okay.
the sunlight is not passing through the atmosphere. The sunlight that's reaching the moon is not passing through the Earth's atmosphere at all.
I'm
Because
saying
that would cause it to.
it's not passing through it at an angle where the wavelength of the red light can get to it. That's what I'm saying. And this is why you don't always see a blood moon, full moon.
And see, I mean, that's the kind of the problem that I have with it is the angles. Like you're talking about reflecting light at an angle off of a sphere. You know what I'm
Okay.
saying? And that being full, that light encompassing that full circle for everybody. You know,
Yeah,
I
because
think
the
the
moon is far
angles
away.
just don't match up. But
Yeah, because the moon is far away. If it was close, why would you expect to see that? For example, you heard of the well, I mean that's during the blood moon. Like when we had a blood moon and the moon was real big.
that's so how come it if the light rays are reaching the moon? I know you're saying it's the shadow, but it's like, damn it. It's just like the y'all think that all the stars are like suns or whatever. And it's like none of those suns are lighting up any of the the space around it. I know it's vast, it's ever expanding, which can't be proven, but anyway, it's ever expanding, but it's just like
Light
I don't believe
reflects
all
off
those
an object.
stars as suns and all of that. That's pretty crazy.
When you saying lighting up things around it, when we look at the solar system, when we see other planets, the sun is lighting up those planets, which allows us to see those planets.
Right. So the
Now,
sunlight,
yeah,
so it's
but
just the atmosphere causing sunlight the way we see it.
yeah, the way we see it from Earth, the blue sky we know is not blue. The sky is not blue. It appears blue, but blue is a color of deception. It appears that way, but it's not that way. The water may appear blue, but it's not actually blue. It is because of the light from the sun, the way it interacts with our atmosphere here on Earth. It makes the sky appear blue. But once we get out of the light of this or the atmosphere, look at it like this. You've seen weather balloon footage, right?
Yeah.
When you go up and you get out of the atmosphere of the earth, The sun, and you look at the sun looks different than it does from Earth. Why is that? It's because you're not looking through the Earth's atmosphere. So you don't see the blue around the sun that you see when you're in a weather balloon. Why? Because it doesn't have atmosphere affecting the light.
Yeah, that makes sense.
So that's one of the things that we must understand when we're looking at the sunlight from Earth versus, or looking at any object from Earth versus looking at it from a cosmic level.
I mean, I guess so. What you're saying is in a void of space, the sun, which you know, that makes sense. That if it's a void, the sunlight's going to act differently in that void,
exactly,
as opposed to the atmosphere or whatever. But still, you know, let's go back to the red shift kind of on the moon. You're saying it's because it's closer, and when it's just a full moon, it's farther away.
And it's at a certain angle, right? You know, and this is something that I had mentioned to a flat earther on a hangout. He was speaking of, he was talking about, and I don't know why it's escaping me now. When, you know, when the moon is big, appears big.
Mm-hmm.
Okay. No matter on the Earth, during that time, the to be bigger, right?
Hold on, say that again. You broke up.
Okay. When you're on the Earth, during that time that the moon appears bigger, 14 up to 14% bigger than it normally is, you can see the moon looking that big, no matter where you're at on the Earth. So my thing is that if the moon was local, how
I don't make that claim though. But you can go ahead with your expert. But I don't.
How would the moon appear bigger to everybody? How would the moon look the same size to everybody on the Earth if the moon is like directly above my head versus somebody else that's thousands of miles away looking at that same moon and it appearing the same size to them too, if the moon was close and local as it appears to be?
Yeah, see, I don't make that claim, and I don't claim to know that the moon is tangible either. But I mean, it's stuff I just don't know.
Okay.
You know?
Well, this is
you don't know it either, but you know.
No, but let me say this. This is what we do know. This is something I was discussing with a flat earther on a comment thread within the last few days, and they mentioned they made a video about the sun, and then they mentioned that the sun is just a light in the sky, like you said. And I said they were alluding that we don't know what it. No, they said that we don't know what the sun is, and they were saying that to justify that that's why the sun appears to set, because they were first saying that it was perspective. Then they said, when I made a comment, then they said, well, it's magnification. And then they said, we don't know what the sun is. And my point is that we live in a physical world with real physical things. We see the sun with our real physical eyes. We feel the heat of the sun with our real physical bodies. The light of the sun shines on real objects and creates real shadows. The heat of the sun burns up and dehydrates and kills people in vehicles. So my thing to flat earthers when using the excuse that the sun is just a light in the sky as a thread person. That is a cop-out answer. Because if you're going to say a thing that you don't know what it is, but what we do know, it has real effects. Its position in the sky is predictable. Okay? Its heat, or the level of heat that we feel from it, is predictable. Those that it creates are predictable. Therefore, whatever you want to say it is not, or you don't know what it is, what we do know is that it's physical, because it has multiple physical effects in our world that we can measure, we can predict, we can judge. Make it something other than that, then you are not seeking truth. You are seeking a narrative that you have accepted.
Oh, I wouldn't say that. I wouldn't go that far to say that I'm accepting a narrative. I'm just merely questioning and maybe seeking out alternative explanations for things that have been written in stone. I think that's all that I'm doing. I'm not, I'm just seeking out alternative explanations for things. And there are alternative explanations. Now, some of them you might not agree with, and we can't, just like you can't go up to the sun, take a piece of it and bring it back to me, proving
but I don't have
to. Okay, so it couldn't.
I'm gonna flip it on you. You can't demonstrate something, right, that doesn't have physical properties.
I'm just saying the source could be different. The source of that light and that heat, it gets kind of into like some kind of projection talk, but I'm just saying that could be.
All of those real examples I just gave for you to, to lean towards that.
I don't deny it. I mean, it's not like flat earthers deny that the sun gives off light and heat. That's not something that, we deny.
Okay. Only when it comes to something that disagrees with the flat earth narrative. The answer is we don't know what it is.
We don't. I mean, that's a fact. You don't think that that's truth? Do you know what it is? Do you know what it is? You may have a good explanation. I mean, if you're just riding with the best explanation, that's fine. But it's always up for challenge. That's just the thing. It's always up for challenge. And this is why I don't like getting into talking to things about the sky and stuff that we can't really like prove here on Earth. It's because it gets into these semantical arguments, and it's like we really don't know. None of us know for sure. And I think I saw something where they sent a probe up to the sun, and see, this is really one of the problems. One of the arguments that it's like, who cares, Joe? Who cares about all of this space travel and stuff when we got a lot of problems going on, on Earth that we need to take care of? We giving all this funding to NASA to do some sketchy stuff and give us sketchy videos, and maybe they did land on the moon, maybe they didn't. What research and how did that help humanity? You know what I'm saying? Like, who cares? Put that money to something. This is why I speak out on it. Put that money somewhere else. We got all of this, things that can lend to free energy or limitless energy to where we're not spending it on fossil fuels and things of this nature. We got wind, we got solar, we got water, we got magnetic energy. Why don't we pull our money to that instead of going off into space trying to prove something? What for? Who cares? I mean, seriously. I mean, that's one of my biggest problems. I'm just letting that be known. None of us can really prove this stuff. NASA is claiming that they are. Congratulations, but How is that? I mean, it's billions and billions of dollars that go to NASA. And to do what? You still there? Jermaine? Guess he didn't cut out again. Let me go to the chat, see if they know anything. Jermaine, you there? Jermaine. Yeah, it messed up again. I guess he's gone again. His icon is still here. It didn't say he that he left like it did last time. Like he left the chat last time.